Welcome to Dogs Information. Frontiers of all, the inner lives of animals. For centuries, people believed that thinking, feeling, and reasoning were uniquely human. But science has begun to reveal something far more astonishing. Across every corner of the planet, from oceans to forests, other creatures are thinking too. They plan, solve problems, and remember complex ideas. They even show signs of empathy, cooperation, and creativity. The more we learn, the more familiar these animals become. And each new discovery leaves us feeling more connected with the natural world. If you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here, too. One sleepy soul at a time. But for now, just breathe. Allow your eyes to grow heavy and your mind to settle. Let's begin. Dogs can detect human emotions through scent alone. The world of scent for a dog is as rich as sight is for us. When a person feels joy, fear, or sadness, their body chemistry changes subtly. Hormones shift, and the odor produced by the skin and breath carry invisible traces of emotion. Experiments using sweat samples from people experiencing happiness or fear showed that dogs responded differently depending on the emotional scent. When they smelled fear, their heart rates increased and they sought comfort from their owners. When they smelled happiness, they became more relaxed and sociable. This shows that their sense of smell reaches far beyond identifying objects or locations. It allows them to perceive human emotion directly through chemistry. They do not need to see a facial expression or hear a tone of voice to know how someone feels. In this way, the bond between human and dog is built on empathy that travels through air itself. Octopuses dream and their skin changes color as they sleep. When an octopus drifts into rest, the patterns on its body begin to shift. Pale shades deepen, spots appear, and colors pulse across its skin in rhythmic waves. Researchers studying these changes notice that they occur in repeating cycles, alternating between stillness and vivid motion, similar to the sleep stages of mammals. During these active periods, the animal's color and texture mimic hunting or camouflage behaviors seen while awake. This suggests that it may be reliving past experiences or rehearsing instincts in a dreamlike state. Unlike most creatures, the majority of its neurons are spread through its arms, creating a distributed nervous system. The body itself becomes part of the mind. When it dreams, the transformation is visible, a living record of imagination written on skin. Observing it is like watching thought take physical form as memories ripple through pigment in the silence of the sea. Dolphins call each other by individual names. In the open ocean, communication is life. Among the most extraordinary examples are the signature whistles of dolphins, which act as vocal names. Each dolphin develops a distinct pattern of sound early in life, shaped by social interaction and learning from others. These whistles allow individuals to identify and call one another even when they are miles apart. When one produces the whistle of another, the recipient often answers, confirming recognition. Such exchanges can persist for many years, showing that these animals maintain long-term memories of social partners. The phenomenon has been tested in controlled settings where recorded whistles of old companions elicit clear responses even after decades of separation. This ability implies not only complex communication, but an awareness of identity and relationship. Their underwater conversations reveal a society organized around memory, trust, and sound. Through these names, they keep their community connected across vast distances of shifting blue water. Crows can recognize human faces for years. Crows live in tight social groups where remembering allies and enemies can mean survival. They extend this awareness to the humans who share their landscapes. Experiments have shown that when a person wearing a particular mask disturbed them, the same crows later reacted strongly to the masked figure even after several years. They warned others and avoided the perceived threat while ignoring neutral faces. Remarkably, new generations learned the same associations without direct experience, demonstrating cultural transmission of information. The birds recognize faces not by simple shape, but by detailed visual features, much like humans do. Their memories appear to be stored long-term and retrieved through recognition rather than mere association. These results show that their intelligence is not just reactive but interpretive. A crow watching a familiar face is accessing a record of past events, emotions, and expectations, maintaining a mental catalog of who can be trusted and who cannot. Elephants comfort each other after grief. Across the plains of Africa and the forests of Asia, elephants form family bonds that endure for life. When a member of the herd dies, others gather around the body. They touch it gently with their trunks, stand beside it for hours, and sometimes return days later to the same place. Observers have recorded them stroking the bones of relatives, lingering in quiet attention. Their behavior changes after such losses. They become subdued, eat less, and stay closer together. When one shows distress, companions approach to offer gentle rumbling calls and physical contact. This social comfort is intentional and consistent, revealing a sensitivity to the emotions of others. The capacity to recognize grief and respond with empathy, as being documented repeatedly in wild and captive groups. These actions suggest that emotional awareness and compassion extend far beyond our own species, existing wherever memory and connection shape the life of a community. Parrots understand the meaning of words, not just the sound. Language requires understanding that words represent things, and some parrots meet that challenge with astonishing skill. Studies involving African gray parrots have shown that they can identify shapes, colors, and numbers. When asked, they respond with accuracy even when questions are rephrased, proving they understand meaning rather than memorized patterns. One famous subject demonstrated the ability to combine familiar words to describe new objects, showing a flexible grasp of concepts. These birds also express preference using speech to request food or refuse items they dislike. They can distinguish quantity, comprehend ideas such as same and different, and recall learned information over time. Such cognitive range points to symbolic reasoning, the foundation of abstract thought. Their communication bridges instinct and comprehension, giving us a rare glimpse into how intelligence evolves when sound and understanding intertwine. Within each exchange lies a small, articulate voice from the wider language of life. Rats laugh when tickled. When gently tickled by a familiar hand, rats emit a burst of high-frequency sounds that resemble laughter when recorded and slowed down. They approach the hand, leap into play, and show signs of enjoyment similar to the way puppies or primates engage in social fun. The reaction disappears if they are frightened, confirming that the response is linked to emotion, not reflex. Researchers have used this playful behavior to study the neural basis of joy, identifying regions in the rat brain associated with reward and affection. These findings challenge old assumptions that small mammals are limited to basic drives. Instead, they show a capacity for social pleasure and trust. The laughter of a rat is silent to our ears but not to theirs. It is the sound of comfort, curiosity, and connection, proving that happiness can take many shapes, even in the smallest beating hearts. Some fish use tools to crack shells. Within coral reefs, certain species of fish display remarkable ingenuity. They capture hard-shelled prey such as clams or crustaceans, carry them to a chosen surface, and repeatedly strike them until the shells break. This requires planning, coordination, and an understanding of cause and effect. Observers have watched the same individuals return to preferred anvil sites again and again, suggesting memory and deliberate selection. The act of manipulating an object to achieve a goal fits the scientific definition of tool use. These fish must visualize the outcome, apply consistent force, and adapt technique when conditions change. For animals long dismissed as instinct-driven, such behavior reveals a surprising mental flexibility. Intelligence, it seems, does not depend on large brains alone, but on the capacity to learn from challenge. Even beneath the waves, innovation arises wherever life meets resistance, and curiosity seeks a way forward. Ravens plan for the future. Among the most intelligent of birds, ravens show a deep awareness of time. In controlled experiments, they were given tools that could later be exchanged for food. They held on to the correct item for many hours, ignoring immediate distractions, and used it when the opportunity finally appeared. This demonstrates foresight, an ability to imagine a future scenario and prepare for it. They also deceive rivals by hiding food in false locations when watched, then moving it once unobserved. To perform such tricks requires memory, patience, and understanding that others have their own perspectives. The planning skills of these birds rival those of primates in complexity. Their actions show that the sense of future is not limited to human thought. Instead, it is a universal solution to survival. Acquired proof that imagination has taken flight in many forms beneath the same sky. Chimpanzees teach cultural traditions to their young. Within forest communities, chimpanzees pass practical knowledge from one generation to the next. Adults use tools to crack nuts, fish for insects, or gather honey. And young individuals watch carefully before attempting the same tasks. Over time, they learn techniques that differ from group to group, creating distinct cultural identities. These customs are not innate. They are taught through demonstration and repetition. In some places, stones of particular shapes are chosen. In others, specific plants are favored. Such variation proves that learning and imitation sustain their societies. Teaching requires patience and intention, traits that reveal empathy and awareness of another's learning process. When knowledge is shared across decades, a community becomes more than a collection of individuals. It becomes a living library of behavior passed hand to hand and mind to mind, preserving the story of experience written in gesture and sound. Bees can understand the concept of zero. Bees are known for navigation and cooperation, but their abilities reach further into abstraction. In laboratory experiments, they were trained to associate patterns with quantities. When faced with an image containing no objects, they treated it as representing a value lower than 1. This means they understand the idea of none, a cognitive milestone once thought beyond insects. To recognize 0, the mind must form a mental placeholder for absence, comparing something that is not there to something that is. Their brains, containing fewer than 1 million neurons, perform this feat through highly efficient neural coding. Such findings suggest that numerical reasoning evolved many times in the history of life. Within the hum of a hive lies not just instinct, but a glimmer of logic, proving that intelligence can emerge wherever complexity and necessity meet. Even the smallest creatures may hold quiet sparks of mathematical thought. Orcas pass hunting techniques across generations. Among the largest predators in the ocean, orcas display cooperation and cultural learning, but rival human traditions. Groups living in different regions use distinct hunting strategies suited to their environment. Some drive schools of fish into tight circles, while others intentionally beach themselves to catch seals near shore, a risky skill taught carefully to younger members. These behaviors are not instinctive. They are learned by observation and practice. Mothers and older pod members act as teachers, guiding the young through repetition and patience. The knowledge persists for generations, forming traditions that define each group. Some populations have unique vocal patterns and dietary preferences as well, reflecting social identity. The sharing of learned technique through time shows that their societies hold memory and continuity. Each pod becomes a living culture shaped by both the ocean's rhythm and the minds that have mastered its many challenges. Pigeons can learn to distinguish between paintings by different artists. Pigeons, often underestimated, possess visual intelligence that has surprised researchers again and again. In controlled experiments, they were shown paintings by artists such as Monet and Picasso. Over time, they learned to peck at one artist's style and not the other, even when presented with paintings they had never seen before. They were not memorizing images, but recognizing artistic features such as texture, color balance, and brush pattern. The results reveal a capacity for conceptual categorization that is rarely found outside mammals. Their ability extends beyond art. Pigeons can identify letters, faces, and even differences between emotional expressions. These birds see the world in detail, and their brains process visual information at remarkable speed. What began as a test of perception became a discovery about cognition, showing that even city birds perched on a ledge may be quietly analyzing the world around them in ways we are only starting to understand. Ants use tiny body signals to teach others. In the hidden tunnels of an ant colony, learning happens through contact and rhythm. When an experienced forager discovers food, she often leads a novice back to the source. The pair travel together in a stop-and-go pattern, the teacher adjusting pace and waiting for the student to catch up. The learner taps her antenna against the leader's body, signaling readiness to continue. This form of communication called tandem running is one of the simplest examples of teaching in the natural world. The teacher sacrifices time and energy to help another learn, proving that even small-raned creatures can display cooperative learning. The behavior shows understanding of both task and student. It is not instinct alone, but deliberate mentorship guided by touch and timing. Through these silent signals, a colony becomes more efficient. Its success shaped by generations of cooperation encoded in the smallest of gestures. Elephants recognize themselves in mirrors. When presented with a large mirror, elephants do something rare among animals. They examine their own reflections with curiosity rather than confusion. They explore parts of their bodies they cannot normally see, moving the mirror to adjust the angle or using their trunks to investigate marks on their faces. In controlled tests where a visible mark was placed on their skin, they touched it directly while looking at their reflection, showing awareness that the image represented themselves. This recognition implies self-consciousness, an advanced form of cognition previously documented mainly in great apes and dolphins. Such awareness supports the idea that these animals possess complex internal models of the self and others. Within their social groups, they show empathy, cooperation, and warming behaviors consistent with deep understanding of identity. The mirror becomes more than glass. It becomes proof of a mind that knows it is looking back at itself. Cleaner wrassfish also passed the mirror test. A small tropical fish once surprised the scientific community by passing a test long considered the mark of higher intelligence. When shown a mirror, the cleaner wrasse first reacted as if facing a rival, then began inspecting its reflection with unusual focus. When researchers placed a visible mark on its body that could only be seen in the mirror, the fish attempted to remove it by rubbing against surfaces. It never attacked the reflection again, suggesting that it understood the image as itself. This discovery forced scientists to rethink how self-awareness might appear in creatures very different from us. The behavior may not mirror human consciousness exactly, but it shows that recognition of one's own body can evolve independently in many forms. In coral reefs filled with color and movement, this small fish quietly demonstrates that self-perception can arise even in the simplest of minds. Horses remember the people who treated them kindly. The relationship between humans and horses has been shaped by memory and trust for thousands of years. Studies have shown that horses can recall the faces and voices of people who interacted with them positively or negatively even after long periods without contact. When hearing a familiar voice associated with gentle care, they show signs of relaxation. When reminded of someone harsh, their heart rates rise and their behavior changes. This emotional memory extends beyond basic recognition. It reflects an ability to connect experience with feeling. The horses use both visual and auditory cues to identify individuals, forming mental associations that influence future interactions. Their sensitivity to tone and posture allows them to read human mood with striking accuracy. The bond formed through kindness leaves a lasting imprint, proving that mutual respect is not only felt, but remembered in the quiet intelligence of the herd. Some birds hide food and pretend to move it when others are watching. In the world of Corvette, deception can be a sign of intelligence. When certain birds hide their food caches, they watch to see if others are nearby. If they sense an observer, they may pretend to hide the food in one place while secretly storing it elsewhere. This kind of misdirection requires understanding that other individuals have their own perspective and might steal the food later. It is an example of what scientists call theory of mind, the ability to imagine what another creature might know or intend. Such strategic behavior was once considered unique to humans and great apes. Yet, these clever birds perform it with ease. Their actions show flexible thinking, memory, and planning. The simple act of burying a seed becomes a lesson in social intelligence, revealing that awareness of others can evolve wherever competition and cleverness share the same sky. Dolphins use sponges as protective gloves while foraging. Along certain coastlines, groups of dolphins have been observed carrying pieces of sponge on their snouts while searching for food along the seafloor. The sponges protect their sensitive skin from sharp rocks and hidden creatures as they dig through sand for fish. This behavior is learned, not instinctive. Mothers teach their calves how to find and use the right sponge, creating a cultural tradition passed through generations. Different groups show variations in technique, suggesting local adaptation and innovation. Tool use in the marine world is rare, yet here it serves as both protection and strategy. It reflects foresight and problem-solving, traits once thought limited to land animals. Within the silent depths, this careful preparation reveals thoughtfulness. Each movement shows an understanding of cause and consequence. A quiet example of intelligence adapted perfectly to the rhythms of the sea. Sea turtles keep a favorite stone for breaking shells. Sea turtles are known for their playful grace, but beneath the floating calm lies skillful craftsmanship. Many individuals select a particular stone they use repeatedly to crack open shellfish. Some keep it tucked under their forearm in a small pouch of loose skin, carrying it wherever they go. The chosen stone often has the perfect shape and weight for their preferred prey. Using it, they strike shells with practiced precision, balancing on their backs as they work. This behavior requires coordination, memory, and a sense of efficiency that borders on tool mastery. Each otter develops its own technique, often refining it over years. Their use of tools shows an understanding of physics in miniature form, proof that intelligence takes many shapes. What looks like a simple mealtime ritual is a display of problem-solving passed quietly through the tides of generations. Gibbons sing duets to strengthen their bonds. In the dense forests of Southeast Asia, pairs of gibbons call to each other at dawn with songs that fill the canopy. These duets are not random sounds, but carefully coordinated performances. Each partner takes turns weaving notes together in rhythm, and the precision of timing reflects the closeness of their bond. Young gibbons learn their family's song patterns as they mature, creating a unique musical identity for each pair. The calls serve both to strengthen emotional connection and to mark territory. Scientists studying their vocalizations found that coordination improves as relationships deepen, suggesting that the psalms function as a form of emotional synchronization. The duets echo through the forest like shared promises, binding mates and families through sound. Their music reminds us that communication can be more than words. It can be harmony built from understanding and trust. Prairie dogs have a complex language with descriptive words. Hidden in the grasslands of North America, prairie dogs communicate using calls so detailed they can describe predators in remarkable ways. Their vocalizations change depending on whether a threat is a human, coyote, or hawk, and even include distinctions for the color or size of a person's clothing. Researchers recorded the sounds and played them back to test reactions, finding that the colony responded specifically to each type of core. This means they are using a structured form of language, not random noise. Their system contains syntax-like features where pitch and rhythm modify meaning. Such sophistication in small mammals challenges assumptions about where language begins. Each chirp carries information that helps the colony survive, proving that meaningful communication can emerge wherever cooperation and intelligence intertwine beneath the open sky. Orangutan make umbrellas from leaves to keep dry. In the rainforests of Borneo and Sumatra, orangutan show a quiet ingenuity born of patience and observation. When heavy rain begins to fall, they gather large leaves and hold them overhead to keep dry. Some fashion the leaves into rough shapes that fit their heads or shoulders. Others use leafy branches as shelter while they rest. These behaviors are learned by watching elders, showing cultural transmission. They also demonstrate tool use based on problem-solving and adaptability. Orangutans spend most of their lives in trees where sudden storms are common. Their ability to create simple protection reveals planning and awareness of cause and effect. The leaf umbrella is not just a response to weather but a sign of imagination at work. In every movement they remind us that intelligence can be as gentle and practical as a single leaf held up to the rain. Wolves strategize together like seasoned teams. When wolves hunt, success depends on coordination and communication. Each member of the pack takes a specific role, adjusting movements based on subtle cues from others. Observations show that they plan routes, predict the prey's direction, and even adapt strategies when something goes wrong. This cooperation is not commanded by a leader but emerges from shared understanding built through experience. Their ability to anticipate one another's actions comes from memory, trust, and the capacity to interpret body language. Studies using GPS tracking have revealed formations that shift dynamically depending on terrain and target. Such complex group behavior mirrors the principles of teamwork in human sports or military planning. It demonstrates that strategic thinking can evolve wherever social life demands unity. In the silence of snow-covered forests, a pack moves like one organism guided by many minds working as a single plan. Elephants understand cooperation instinctively. When faced with a task requiring teamwork, elephants grasp the concept almost immediately. In experiments where two animals had to pull ropes simultaneously to access food, they quickly learned to wait for their partner before acting. If one arrived too early, it would pause and look back, ensuring the other was ready. This shows awareness that success depends on mutual effort. In the wild, cooperation appears in how they protect calves, clear paths, or lift fallen companions. Their social intelligence is woven into daily life. The ability to coordinate actions based on shared goals demonstrates understanding of cause, timing, and collective outcome. They do not compete for credit. They simply know that working together achieves more. This instinctive sense of collaboration reveals empathy and strategic thought combined. It is a reflection of deep connection, both emotional and cognitive, among the giants of the savannah. Ravens trade objects for rewards like currency. In studies exploring problem solving, ravens were given objects such as bottle caps or tokens and taught that these items could be exchanged for food. They quickly learned the association and began saving valuable objects for future use. Some even chose to keep tokens instead of taking immediate lesser rewards, showing understanding of delayed gratification. Their interactions with researchers resembled primitive trade systems where symbolic items represented value. Ravens also use objects socially, gifting or withholding them to influence relationships within their groups. The behavior combines memory, reasoning, and social awareness. It suggests that they can assign worth to neutral items, an important step in abstract thinking. Watching them barter offers a glimpse of cognition that blurs the boundary between instinct and economy, proving that intelligence can invent its own forms of value wherever curiosity and opportunity meet. Some parrots invent new words to describe things. Certain parrots raised with human companions have demonstrated creative language use that goes beyond repetition. When encountering unfamiliar objects, they sometimes combine known words to describe them. One individual famously referred to an apple as a banana berry after learning both words separately. This inventive blending shows that they can apply logic and analogy to new experiences. The ability requires flexible memory and an understanding that words represent categories rather than fixed labels. It also suggests a desire to communicate meaning rather than simply imitate sound. Their minds organize language conceptually much like children developing vocabulary. Each act of invention reveals imagination and problem-solving within the realm of speech. Such behavior transforms communication into creation, reminding us that intelligence seeks not only to learn, but to express the world in its own unique voice. Dolphins use signature whistles to reunite after separation. When separated from their group, dolphins produce specific whistles that identify who they are. Each individual's core functions as a unique name, recognizable across large distances underwater. Recordings show that when one broadcasts another's signature sound, the named individual often responds, allowing them to locate each other. The accuracy of recognition remains consistent even after years of absence, proving long-term social memory. This form of communication maintains unity in vast ocean spaces where vision fails. The exchange of these vocal signatures represents a form of personal identity and social cohesion rarely seen in non-human species. It allows friends, relatives, and allies to stay connected through complex networks of sound. Their voices move through the water like strands of connection, weaving families together beneath the shifting waves and turning the ocean into a living web of memory and core. Scrub jays remember who was watching when they hid food. Scrub jays possess extraordinary memory and social awareness. When they hide food, they keep track of who might have seen them do it. If another bird was present, they often return later to move the cache to a new location once the observer is gone. Birds that have stolen from others in the past are especially cautious, as if projecting their own motives onto rivals. This shows understanding that others can hold different knowledge or intentions. Experiments have demonstrated that they can remember specific events, including the time, place, and social context of a hiding act. This form of mental time travel connects memory and anticipation in a single thought process. Their strategic planning reveals that foresight and self-reflection are not limited to large brains. In the mind of a scrub jay, the future and the past meet in the clever act of keeping secrets safe. Bees can be trained to recognize human faces. Although their brains are incredibly small, bees process visual information with astonishing efficiency. In controlled studies, they were trained to associate photographs of human faces with rewards. Over time, they learned to identify individual faces, even distinguishing new angles or lighting conditions. The bees did this by breaking the image into recognizable patterns of contrast and spacing, forming mental templates that allowed for recognition. This capability shows that complex facial perception does not require a large brain, but an optimized one. The research has applications in understanding artificial vision systems and biological efficiency. It also expands our view of insect intelligence, revealing that their minds can process visual complexity in ways once thought impossible. In the delicate hum of their work, these small creatures quietly remind us that cognition can exist in even the tiniest architectures of life. Bonobos use eye contact to resolve conflicts peacefully. Deep in the forests of the Congo Basin, bonobos live in communities where balance and calm take priority over dominance. When disagreements arise, they do not resort to violence, but use subtle social cues to restore harmony. Eye contact is one of their most profound tools. After moments of tension, individuals meet each other's gaze, signaling reassurance and reconciliation. Researchers have observed that mutual staring often occurs just before or after peaceful gestures such as grooming or touching hands. This deliberate exchange helps lower stress hormones and rebuild trust within the group. By recognizing one another's emotions through facial cues, they practice a level of empathy rarely seen outside humans. Their approach to conflict resolution relies on cooperation rather than fear. It reflects an intelligence grounded in emotional understanding where stability is achieved not through power but through compassion expressed in the quiet depth of shared eyes. Dolphins help injured friends stay afloat. In the open sea, where survival depends on cooperation, dolphins display extraordinary care for one another. When a member of the pod becomes weak or injured, others move to its side, keeping it near the surface so it can breathe. They adjust their speed, angle, and rhythm together, matching the disabled individual's movements. Some remain in position for hours or even days, taking turns to prevent exhaustion. Scientists studying this behavior have concluded that it cannot be explained by instinct alone. It reveals awareness, empathy, and an understanding of another's physical state. On rare occasions, dolphins have even helped animals of other species, including humans, guiding them to safety. Their willingness to share energy for the sake of another's survival shows a moral depth woven into their social fabric. Within these quiet acts of support, the ocean's vastness becomes a stage for compassion unfolding between minds attuned to care. Crows drop nuts on roads so cars can crack them open. City crows are masters of adaptation. They have learned to use the rhythms of human life as tools for their own survival. In busy intersections, they place hard-shelled nuts directly in the path of oncoming cars, then wait on lampposts as the vehicles roll past. The pressure cracks the shells perfectly. When the traffic stops at red lights, the birds swoop down to collect their meal before the next wave of cars arrives. Researchers studying this behavior found that the birds understand the pattern of lights, avoiding danger by timing their movements with precision. This reveals awareness of human systems and the ability to anticipate events. They also teach younger crows the same technique, passing along knowledge across generations. What appears to be a simple act of scavenging is in fact an elegant example of urban intelligence where nature learns to collaborate with civilization. Spiders adjust their web designs when on psychoactive substances. The geometric precision of a spider's web reflects not just instinct, but neural balance. Decades ago, researchers exposed spiders to small doses of various substances, including caffeine, sedatives, and stimulants. The results were striking. Under the influence of caffeine, their webs became erratic and asymmetrical with missing connections and tangled strands. Sedatives produced simple, sparse designs that still retained structure but lacked detail. These outcomes showed that web construction mirrors the spider's mental state, much like handwriting changes under stress. By analyzing these patterns, scientists gained insight into how chemicals affect coordination, focus, and sensory feedback. Although the experiments raised ethical questions, they demonstrated that even creatures with tiny brains rely on complex neural control to perform their delicate art. Each strand of silk reflects concentration and rhythm. When that rhythm is altered, the entire architecture of the web transforms, revealing the invisible mind behind the silk. Elephants return to the bones of the dead. In the savas and forests where elephants roam, memory is a living force. Years after a herd member dies, others return to the remains, touching the bones with their trunks and feet. They pause in silence, sometimes for long minutes, tracing tusks and skulls as if remembering the life once carried within. They ignore the remains of other species, focusing only on their own kind. Calves learn this solemn behavior by watching adults, suggesting that it is a shared tradition rather than simple curiosity. Some individuals revisit the same places years apart, demonstrating powerful spatial memory. Researchers believe these moments represent both mourning and connection. It is as though elephants hold a map of relationships within their minds, one that persists beyond death. Through these tender gestures, they remind us that memory and love can linger in the spaces where life once stood. Whales sing in dialects unique to their pods. The songs of whales are among the most haunting sounds in nature, carrying for hundreds of kilometers through water. Each group of whales develops its own version of the song, shaped by geography, lineage, and history. These patterns function like dialects, allowing individuals to recognize members of their pod. Over time, the psalms evolve, adding or dropping phrases, blending old motifs with new variations. When pods meet, their music sometimes merges, reflecting cultural exchange through sound. Young whales learn these melodies by listening and mimicking adults, preserving their heritage through generations. Acoustic analysis shows that these songs follow structured patterns, almost like musical grammar. Beyond communication, they serve as memory maps, recording the shared identity of a group as it moves through the sea. Each note that echoes beneath the waves carries both information and ancestry, linking voices across vast stretches of blue. Some fish can count small numbers within the shimmering world beneath the surface. Counting can mean survival. Small fish such as guppies, angelfish, and zebrafish display numerical awareness by consistently choosing to swim toward larger shores for protection. This ability helps them reduce the risk of predation as safety increases with numbers. Experiments revealed that they can distinguish between groups of 2 and 3 or 3 and 4, though the skill weakens when quantities become close in size. Scientists call this ability subitizing, a rapid instinctive recognition of quantity without formal counting. Even when shown patterns of shapes or dots, they identify the larger number, proving that the skill is not limited to social behavior. This discovery suggests that basic arithmetic perception may be ancient, predating complex brains. Beneath the scales and ripples, mathematics begins as instinct, guiding life through balance, choice, and the subtle geometry of the ocean's rhythm. Dogs understand dozens of human words and gestures. Through thousands of years of companionship, dogs have developed an extraordinary ability to interpret human language. Many can learn hundreds of verbal cues linking words to specific objects, people, or actions. They can differentiate between toys, follow multi-step commands, and recognize emotional tone. When humans speak, dogs process words in the left hemisphere of their brains and tone in the right, mirroring the way humans interpret speech. They also respond to gestures such as pointing and eye direction, demonstrating a deep sensitivity to communication intent. In experiments, they correctly select named objects even when multiple unfamiliar options are presented, showing genuine understanding rather than mere conditioning. Their minds translate sound into meaning and meaning into action. Each shared glance or spoken phrase reinforces a partnership built on trust and empathy. Through this remarkable connection, two species have learned to think together without the need for shared speech. Apes can learn sign language to communicate complex ideas. Over decades of study, researchers have taught several apes, including chimpanzees, gorillas, and bonobos, to use modified sign languages designed for cross-species communication. These apes have learned hundreds of distinct signs, combining them into meaningful phrases to express needs, desires, and observations. Some even invent creative combinations to describe unfamiliar objects, demonstrating understanding rather than rote memory. One gorilla used signs to express emotions like happiness, sadness, and affection, revealing an inner world rich with thought. Their ability to grasp symbols shows that language is not a uniquely human skill, but a continuum of intelligence shared across species. Through this learning, they exhibit patience, reasoning, and imagination. Each conversation becomes a meeting point between two minds, shaped by evolution, but united by the urge to connect. The exchange of gestures transforms communication into mutual discovery, proving that the essence of language is the desire to be understood. Bees share the location of flowers through dance. Within the hive, light barely filters through. Yet, thousands of bees communicate with remarkable accuracy. A returning worker performs a pattern of movements known as the waggle dance, turning in circles and vibrating her body at specific angles. Each detail of the dance conveys information about the direction, distance, and richness of a nectar source relative to the sun. Observers within the hive watch closely, decode the message, and depart toward the same destination. This system adjusts for the movement of the sun throughout the day, requiring a form of calculation and memory. It transforms collective behavior into a synchronized exploration of the world beyond the hive. Through these movements, energy and knowledge flow together, ensuring the success of the entire colony. The dance is more than coordination. It is a living example of how complexity and cooperation can arise from the smallest of minds. Rats show empathy and free trapped companions. Inside laboratories designed for behavioral study, scientists once placed a rat in a transparent chamber while another moved freely nearby. When the free rat discovered how to open the door, it repeatedly did so, even when no reward was given. Faced with a choice between rescuing the trapped companion or eating chocolate, many chose to help first. The behavior became stronger when the pair were familiar, suggesting emotional connection. Researchers proposed that rats experience empath-like responses rooted in social bonding. They become agitated when others show distress and calmer when others are at ease. This recognition of another's emotional state suggests shared feeling rather than instinct. These experiments remind us that compassion is not exclusive to complex primates. It may emerge anywhere life forms bonds strong enough to feel the difference between another's suffering and safety. Octopuses use coconut shells as portable homes. On the seafloor, beneath scattered coral and debris, octopuses practice one of nature's most resourceful behaviors. They collect discarded coconut shells, sometimes carrying halves across the sand for many meters before finding the perfect spot to use them. Once settled, they fit the shells together to form shelters, retreating inside at the first sign of danger. This shows planning, spatial awareness, and understanding of future needs. Some individuals even reuse the same shells repeatedly, proving memory and preference. Tool used like this is exceptionally rare among invertebrates, marking a striking level of intelligence. The octopus assesses shape, weight, and texture, manipulating its environment as a craftsman might handle materials. Each movement reflects foresight, turning a fragment of human waste into protection. On the ocean floor, ingenuity gleams quietly, transforming discarded objects into signs of independent thought. Beneath the waves, magpies recognize themselves in reflections. When magpies encounter a mirror, their reactions reveal insight far beyond curiosity. At first, they may show aggression, thinking the reflection a rival. Soon after, their behavior changes. They adjust feathers, examine markings, and investigate parts of their bodies visible only in the mirror. In controlled tests, scientists placed colored marks on their feathers, and the birds attempted to remove them, proving awareness that the image was their own. This discovery stunned researchers because magpies are birds, not mammals, and their brain structure differs significantly from primates. Yet, the result demonstrated that consciousness can take many neurological forms. These observations reveal not only self-recognition, but also a sense of individuality. In that fleeting moment of reflection, a bird perceives itself as a being distinct from the rest of the world, proving that awareness may shimmer wherever intelligence learns to look inward. Dolphins work together to herd fish into bait balls. In the blue depths of the sea, coordinated hunting becomes an art form. Groups of dolphins gather around schools of fish moving in near-perfect unison. They drive the prey into a dense sphere, a structure known as a bait ball. Some create spirals of bubbles to trap the fish, while others dart in to feed. The timing is exact, guided by rapid bursts of sound used for communication. Each dolphin knows when to move and when to wait, forming a dynamic system of teamwork. In some regions, they even coordinate with human fishermen, signaling when to cast nets and sharing in the catch. This collaboration passed through generations represents culture within another species. Their hunting is not chaotic, but strategic based on planning and rhythm. Beneath the waves, these synchronized movements become a living symbol of shared intelligence at work. Chimpanzees remember faces of other chimps for decades. Memory weaves through chimpanzee society like an invisible thread. In experiments using digital screens, researchers showed chimps photographs of individuals they had not seen for more than 20 years. The responses were immediate. Their attention lingered on familiar faces, accompanied by calm and interest rather than surprise. Such enduring recognition indicates that social memory plays a crucial role in their lives. It helps them maintain alliances, recall past conflicts, and identify friends in ever-shifting communities. Their minds hold not just visual images, but emotional associations tied to those memories. This level of recall rivals human capacity and reveals that memory among primates extends far beyond practical use. Each remembered face carries the weight of shared experience, stored quietly within the mind and recalled when the eyes meet once again. Ravens hide tools for later use. In forests and rocky plains, ravens collect sticks, stones, and other useful objects, caching them in hidden locations for later tasks. They remember where each tool is kept and return when the need arises, sometimes days or weeks later. Experiments show that they prefer tools suited to specific challenges, proving understanding of cause and effect. They also conceal their actions if other ravens are nearby, demonstrating awareness of potential theft. Such planning and secrecy point to advanced foresight and self-control. These birds are not simply reacting to the present. They are preparing for the future. Their actions mirror some of the earliest human problem-solving strategies where intelligence meant imagining what might be needed tomorrow. Through their hidden stores, they display the same logic that built the first steps of invention. Buried quietly beneath feathers and time. Dogs can feel jealousy when owners show affection to others. Anyone who has lived with a dog knows the way it reacts when attention shifts away. Scientists confirmed this emotion through controlled experiments showing that dogs behave differently when their humans focus on another animal or even a realistic toy. They push between, nudge or bark, trying to restore contact. The response cannot be explained by confusion or play. It stems from social comparison. The emotional pattern aligns with jealousy, an instinct that helps preserve important relationships. This feeling supports long-term bonding by motivating loyalty and awareness of attention. Brain scans reveal that the same emotional centers active in human jealousy light up in dogs during such moments. It suggests that the architecture of emotion may be far older than humanity itself, carried through the shared history of companionship and the silent need for connection that defines all social life. Ant colonies function like superorganisms with distributed intelligence. A colony of ants operates as a living system where thousands of individuals act in perfect coordination without central control. Each ant follows simple local rules, but together they create intricate outcomes, building tunnels, farming fungi, or organizing defenses. Information spreads through pheromones which act as chemical messages guiding behavior. When conditions change, the colony adapts instantly, redirecting workers and reallocating tasks. This self-organizing system mirrors the principles of computation where many simple units produce complex intelligence. Scientists studying ant behavior use it to design algorithms for robotics and networks, drawing inspiration from nature's collective problem-solving. The colony behaves as if it were one vast mind distributed across many bodies, each contributing awareness to the whole. Within these tiny architects lies a demonstration of how intelligence can emerge not from a single brain but from connection itself. Horses communicate with humans using symbols. In recent studies, horses learned to use visual boards containing simple symbols that represented choices. When given the option to request a blanket, remove it, or make no change, they consistently indicated their preferences using their muscles. Their selections reflected weather conditions and comfort, suggesting awareness rather than random action. The ability to connect symbol with meaning shows conceptual understanding and memory. It also reveals that communication between species can occur through mutual learning rather than command. These animals understand human attention and anticipate response, creating a genuine exchange. The discovery challenges assumptions about the limits of nonverbal communication. It proves that intelligence can bridge the gap between species when both sides listen. Each choice made with quiet precision is a message sent across the divide between minds, where cooperation becomes conversation. Whales have family histories passed down through song. Across the world's oceans, whale songs serve as chronicles of time and kinship. Each population maintains its own melody, a sequence of tones and rhythms that shift subtly as generations pass. Young whales learn these songs from elders, carrying them across thousands of kilometers. Over decades, melodies change, absorbing new elements while preserving echoes of the past. Scientists can trace lineages and migration routes by comparing the evolving structures of these songs. The patterns reveal contact between distant pods and record the passage of culture through sound. The psalms are not random. They follow repeating phrases and patterns that resemble the grammar of music. They are the ocean's oral history, telling who these whales are and where they have been. Beneath the waves, memory and identity travel together in sound, linking the living to the voices of ancestors still resonating. Through water and time, cuttlefish can delay gratification like children in the marshmallow test. Cuttlefish have shown an unexpected level of self-control that rivals the intelligence of many land animals. In a carefully designed experiment, researchers placed them in front of two potential meals: an immediate, less preferred piece of food and a favored shrimp that would only be available after waiting. The cuttlefish that resisted temptation received the better reward. Many of them turned away from the first offering, almost as if avoiding distraction. Some waited for more than 2 minutes, a considerable span for such small creatures. This behavior demonstrates the ability to connect present restraint with future gain, an advanced cognitive skill known as delayed gratification. Their brains, though very different from ours, contain complex lows that support learning and memory. These studies suggest they can evaluate outcomes, imagine alternatives, and make intentional choices. Deep beneath the waves, their intelligence quietly challenges what it means to plan, decide, and wait for something better. Gorillas use body language to joke and tease. Within their family groups, gorillas often engage in playful mischief. Researchers have observed individuals who deliberately surprise others, steal objects, or perform false gestures before retreating with apparent amusement. They sometimes glance back at their companions, seemingly to gauge reaction, and then repeat the behavior when it elicits laughter-like responses. Such teasing is not aggression. It strengthens bonds and builds trust through shared experience. The capacity for humor requires an awareness of expectation and the ability to subvert it intentionally. Gorillas understand social rules well enough to bend them for fun. In doing so, they reveal an emotional sophistication similar to our own. The spark of humor also signals empathy since the teaser must anticipate how another will feel. These gentle pranks show that play and laughter are not limited to humans, but are woven into the emotional fabric of many intelligent beings who seek joy and connection. Dolphins cooperate with humans in fishing traditions. In southern coastal communities of Brazil and Myanmar, dolphins and humans work side by side in a partnership that has endured for generations. The dolphins herd schools of fish toward the shoreline, driving them into tight clusters. At just the right moment, they signal the fishermen by slapping their tails or leaping from the water. The humans then cast their nets, capturing part of the school while the dolphins feed on the rest. Both sides benefit, and both have learned to trust the timing of the other. Young dolphins appear to learn the behavior by watching older members, just as young fishermen are taught by their elders. This interspecies tradition reflects not instinct but culture passed down through teaching. The coordination requires shared attention, understanding of cues, and a form of communication that bridges species. Stands as one of the most profound examples of mutual cooperation between humans and another intelligent life form. African gray parrots understand concepts of size and shape. African gray parrots are renowned for their advanced intelligence and ability to grasp abstract ideas. In controlled experiments, they demonstrated understanding beyond simple recognition of colors or objects. When presented with pairs of items, they could identify which was larger, smaller, rounder, or different in shape, even when encountering new examples they had never seen before. Some individuals could describe the attributes aloud using learned words, accurately identifying categories rather than just repeating sounds. Their cognitive skills include symbolic reasoning, a foundation of logic and mathematics. These parrots apply learned principles to novel situations, proving comprehension rather than imitation. Their behavior shows flexible thought and problem-solving ability comparable to that of a young child. Inside the bright feathers and small skull lies a brain capable of linking perception with abstract understanding, turning vision, memory, and sound into a unified awareness of the world's intricate relationships. Sea lions can understand abstract rules and patterns. Sea lions possess a reasoning ability once thought exclusive to humans and primates. In a series of laboratory studies, they learned to identify relationships between symbols even when the actual objects changed. For instance, if shown that one image was associated with another, they could infer the link between new pairs following the same rule. This process, called transitive inference, demonstrates logical reasoning that extends beyond simple association. The animals recognized patterns hidden within data and applied them to unfamiliar contexts. Their performance suggests an understanding of equivalence and relation, abstract ideas that lie at the core of reasoning. Such mental flexibility reflects a brain capable of building concepts rather than merely reacting to stimuli. Sea lions use these cognitive tools in the wild to navigate complex social structures and variable environments, balancing instinct with intelligence in the quiet rhythm of ocean life. Cats use their purring to influence human behavior. The soothing sound of a cat's purr carries layers of hidden meaning. While often a sign of comfort, it can also be a carefully tuned form of communication. When a cat wants attention, food, or care, it subtly alters the pitch of its purr to include a faint high-frequency element resembling a human infant's cry. This particular sound triggers instinctive nurturing responses in people. Studies have shown that humans respond faster and more positively to these modified purrs than to ordinary ones. Over thousands of years of companionship, cats have learned to manipulate human perception through sound alone. The purr becomes both expression and influence, a bridge between species built on emotional resonance. It reveals how deeply interwoven human and feline evolution has become, shaping a shared language of comfort and persuasion that hums softly in the space between affection and instinct. Spiders can count steps when rebuilding webs. Spiders construct their intricate webs with astonishing precision, even when visual cues are limited. When sections of a web are removed, they rebuild them nearly perfectly, as if guided by an invisible plan. Researchers discovered that they appear to measure distance through movement, counting leg steps to determine spacing between anchor points. This internal calibration functions like an organic measuring system. When conditions change, such as when the wind shifts or the structure bends, they adjust their patterns accordingly. Even in darkness, the accuracy remains, showing that web construction depends more on spatial memory and proprioception than sight. Every spiral and strand reflects a sequence of counted motions, forming a geometric map built from instinct and calculation. This biological engineering illustrates how even small nervous systems can produce complex and consistent designs. Through rhythm, repetition, and the quiet mathematics of motion. Capuing monkeys reject unfair treatment. Capuchin monkeys exhibit a clear understanding of fairness and social balance. In carefully designed experiments, Pairs of monkeys performed identical tasks but received unequal rewards. When one received a more desirable treat, such as a grape, while the other received plain cucumber, the disadvantaged monkey often refused the food or threw it back in protest. Their reactions grew stronger when the inequity persisted, suggesting a genuine sense of injustice. This behavior promotes cooperation by discouraging exploitation within their groups. Fairness for them is not a human invention but an evolved mechanism to maintain harmony and trust. These emotional responses show awareness of others' circumstances and expectations. When equality is respected, the monkeys resume cooperation without conflict. Their sense of justice is not abstract morality, but a practical reflection of empathy and balance, revealing that the roots of fairness stretch deep into the evolutionary fabric of social life. Elephants use tools to scratch hard-to-reach itches. Elephants have long been admired for their intelligence, and one of their more endearing behaviors is tool use for comfort. When faced with an unreachable itch or irritation, they will break off branches or select sticks of suitable shape to reach the exact spot. Some even adjust the size and remove leaves to make the tool more effective. This demonstrates problem-solving and body awareness, as they must visualize their own form and the action needed to resolve discomfort. Such behavior requires planning and adaptability, qualities linked to higher cognition. Tool use of this kind reveals curiosity and a capacity for invention. Elephants approach the challenge with calm persistence, testing and refining their methods. What might seem like a simple act of scratching is in fact a glimpse into a complex mind capable of transforming the environment to serve personal need. Guided by intelligence and memory, dolphins recognize each other's voices even after decades. In the vast expanses of the sea, where visibility fades quickly, dolphins rely on sound to maintain their intricate social lives. Each develops a unique signature whistle early in life, functioning like a name. Remarkably, they can remember and identify these sounds decades later. In controlled studies, when recordings of long-separated companions were played underwater, the dolphins responded instantly, calling back in clear recognition. They ignored unfamiliar calls, proving that this memory is specific and enduring. Such long-term recall implies deep social bonds and a sophisticated auditory memory unmatched by most other animals. Their voices hold not just identity, but history, linking them across time and distance. Within those brief melodies lies the continuity of friendship and kinship carried through waves. It reveals an intelligence shaped by emotion, communication, and the enduring resonance of connection. Whales may experience something like grief. When a whale loses a calf, the reaction of the mother often mirrors mourning. For days, sometimes weeks, she will carry or support the body, gently nudging it toward the surface. Companions often slow their travel and remain nearby, producing low rhythmic calls. These actions are costly in energy and risk, yet they persist. Scientists believe this behavior expresses emotional attachment and an inability to release the bond immediately. Such tenderness implies awareness of loss, a mental connection between presence and absence. The repeated observations of this behavior across species suggest that grief may arise wherever affection and memory coexist. Though we cannot know their inner feelings, the persistence and care speak of love that does not vanish with death. In the quiet depths, their mourning becomes a wordless testimony to empathy as ancient as the sea itself. Ravens remember past injustices and hold grudges. Ravens possess a sharp memory and an acute sense of fairness. When individuals interact with humans who deceive or withhold rewards, they remember those encounters vividly. In later trials, they avoid or even retaliate against those same people while cooperating with generous ones. They also observe others' experiences and draw conclusions, refusing to trust those who acted unfairly toward fellow ravens. This behavior demonstrates social reasoning, moral evaluation, and emotional memory. They form impressions of reliability and act accordingly, suggesting a mind capable of judgment. Such understanding supports complex social hierarchies in the wild where cooperation and competition coexist. Their grudges are not petty instincts, but calculated responses to past experience. It is a sign of intelligence that remembers not just faces and voices, but the moral weight of interaction, proving that memory and emotion shape even the keen eyes of the crow's dark kin. Octopuses can solve mazes after only a few tries. In laboratory studies, octopuses displayed a remarkable ability to learn through exploration. When introduced to mazes with hidden exits or small puzzles containing food, they quickly discovered solutions. After only a few attempts, they could navigate directly to the goal on subsequent trials, revealing spatial memory and an understanding of layout. Some even opened jars or released latches to obtain rewards, demonstrating dexterity and insight. Their nervous systems with most neurons distributed through their arms allow each limb to act semi-independently while sharing information with the brain. This arrangement creates a worked intelligence capable of parallel problem solving. They remember successful strategies for weeks, applying learned techniques to new challenges. Their curiosity drives experimentation and adaptation, qualities linked to consciousness itself. Within those fluid movements hides a quiet mind of remarkable depth. A thinker that learns not through speech but through sensation, pattern, and touch. Wolves understand fairness in food sharing. Wolves live in close-knit packs where cooperation ensures survival. After a hunt, they distribute food according to contribution and rank, maintaining balance within the group. In experimental settings, wolves performing cooperative tasks refused to continue when rewards were unequal. They reacted visibly to unfair treatment, showing emotional frustration and awareness of equity. When treated fairly, cooperation resumed without hesitation. This reflects an understanding of fairness similar to that seen in primates. The behavior strengthens social bonds and prevents conflict, revealing that empathy and justice are vital even in harsh environments. Wolves know who shares and who does not, and they remember it. Their lives depend on trust built through fairness. Within their silent coordination lies an ancient moral code. Equality sustains unity and unity sustains life. It is an instinct refined by reason, expressed through loyalty, patience, and the quiet balance of the hunt. Some birds use hooked twigs to fish for grubs. In forests across the world, certain birds display ingenuity that rivals tool-using primates. They select slender twigs, fashion them into hooks, and use them to extract insects from tree bark. Some modify the tools by trimming leaves or bending the ends to improve grip. Others carry favored tools from site to site, showing memory and foresight. This behavior demonstrates an understanding of cause and effect. They know that the object, once shaped, can extend their reach. It requires patience, precision, and learning through experience. Young birds watch adults before attempting the craft themselves, indicating cultural transmission. These small acts of creation blur the line between instinct and innovation. In each delicate movement lies a fragment of thought, an echo of invention written in feather and twig. Through their quiet craftsmanship, they remind us that creativity is a universal expression of intelligence. Orangutan craft musical instruments from leaves. In the dense canopies of Southeast Asia, orangutans sometimes pluck broad leaves, press them against their mouths, and blow to produce resonant sounds. These leaf instruments vary in tone, depending on thickness and moisture, and individuals appear to experiment until they find the pitch they prefer. The behavior serves both practical and playful functions, possibly amplifying calls or expressing excitement. Young orangutans observe and imitate adults, suggesting that the tradition is passed through learning rather than instinct. The act requires planning, motor coordination, and curiosity. It reveals an appreciation for sound itself, an early spark of creativity found in nature. Through this spontaneous artistry, they show that intelligence seeks not only survival but expression. The forest becomes a stage where music, communication, and play intertwine, turning leaves into instruments and life into performance. Dolphins understand grammar-like patterns in human speech. Dolphins are capable of recognizing structure within communication, not just isolated sounds. In studies spanning decades, researchers taught them sequences of whistles and gestures that followed grammatical rules. The dolphins learned that the order of cues changed meaning. For example, the same words presented in a different sequence produced distinct responses. They understood these differences consistently, proving awareness of syntax. Such ability reflects symbolic reasoning and flexible cognition. Their comprehension extends beyond imitation, showing that they process information according to relational patterns. This means their communication systems could be more structured than previously believed. The findings reveal that intelligence evolves in diverse forms, adapting to environment and need. Within the ocean's quiet language of sound, their minds build meaning from pattern, rhythm, and memory, creating a subtle grammar of thought that mirrors our own in depth and complexity. Bats recognize individual voices within their colonies. Inside a dark roost where thousands of bats cluster together, each one can still identify familiar voices. Mothers locate their pups among countless others through subtle differences in pitch and rhythm. Friends and mates also recognize one another by call alone. These vocal signatures act like names, forming a complex social network maintained entirely by sound. Recognition depends on memory and auditory precision similar to human voice identification. This skill allows coordination of feeding, mating, and rest within crowded spaces where vision is useless. Experiments show that when recordings of familiar calls are played, bats respond immediately, even after long absences. Their perception of individuality through sound challenges assumptions about small-raned creatures. Within the chorus of squeaks and echoes lies a hidden world of relationships held together by memory, familiarity, and the quiet power of recognition. In darkness, chimpanzees console each other after conflicts. After fights within their communities, chimpanzees often display gestures of reconciliation. Those not involved in the conflict approach the distressed individuals, offering touches, embraces, or gentle grooming. These actions reduce stress and repair damaged relationships. The behavior reflects empathy and emotional intelligence as chimps adjust their responses to the intensity of another's distress. Individuals with strong social bonds are especially likely to offer comfort. This shows understanding of others' emotions and a motivation to restore peace. Such acts are not demanded by dominance or reward but by compassion. Through these interactions, group harmony is preserved, ensuring cooperation in the complex web of their society. Their gentle reconciliation reminds us that the roots of empathy and kindness reach far beyond humanity, existing wherever connection and understanding sustain life in shared community. Birds can imagine future scenarios to plan actions. Scrub jays have revealed an astonishing ability to think ahead. In experiments, they cached food in places where they expected to be hungry later, adjusting choices depending on what they anticipated would be available. They also avoided storing perishable items in warm spots, showing awareness of time and decay. This kind of mental projection known as future planning requires remembering past experiences and simulating events not yet real. It bridges memory, imagination, and foresight, traits once thought uniquely human. When faced with changing conditions, they adapt their strategies flexibly. This capacity suggests an inner world rich with possibility where thought extends beyond the present moment. In their quiet preparation lies a reflection of human planning itself. Proof that even small minds can hold the seed of tomorrow within the patterns of today. Dolphins synchronize their heartbeats when swimming together. When dolphins glide through the ocean in pairs, their movements seem effortlessly coordinated. But beneath that graceful rhythm lies an even deeper connection. Researchers using specialized monitors have discovered that when close companions swim side by side, their heartbeats gradually begin to synchronize. This remarkable phenomenon occurs most strongly between bonded individuals, suggesting that emotional closeness influences physiology. The synchronization likely arises because dolphins must match breathing patterns, swimming speed, and even subtle muscular tension. The effect mirrors findings in humans whose heart rhythms can align during shared moments of music or affection. For dolphins, this unity may serve to reinforce trust, cooperation, and awareness of each other's states. When danger threatens or opportunities arise, their reactions align instantly, guided by this invisible rhythm. The ocean becomes not just their habitat, but their shared pulse. A living expression of companionship where thought, motion, and heart converge in perfect harmony beneath the waves. Bees can experience optimism and pessimism. Though they live brief lives and operate within tiny brains, bees appear capable of emotion-like states that shape how they interpret uncertainty. In experiments, researchers trained bees to associate one scent with a sweet reward and another with a bitter taste. When exposed to ambiguous scents after a stressful jolt, the bees approached more hesitantly, as if expecting disappointment. Yet, when given a pleasant reward beforehand, they flew confidently toward the same unknown cues. This behavioral shift mirrors optimism and pessimism in mammals, suggesting that mood influences their decision. Neurochemical testing revealed that dopamine, a molecule central to human happiness, rises and falls in bees depending on experience. Their mood becomes a lens through which they judge risk and reward. In this way, emotion guides choice, helping them adapt to unpredictable conditions. Beneath their delicate wings and simple forms lies a complex awareness, an echo of feeling that connects instinct to anticipation and transforms reaction into reflection. Crows understand the physics of water displacement. Crows have proven that the grasp of physical law is not limited to human thought. In carefully designed studies, researchers placed food floating inside narrow water-filled tubes just beyond reach. The birds began dropping pebbles into the water, raising the level until the food floated high enough to be retrieved. They ignored light or floating materials, choosing heavier objects that produced the desired effect. Their precision demonstrates an understanding of cause, weight, and displacement. When the experiment was modified with different tube sizes or water levels, they adapted immediately, revealing flexible reasoning rather than rote behavior. The understanding of how action changes environment mirrors the logic of experimentation. Their behavior rivals that of young children tested under similar conditions. Watching a crow drop a single stone, pause, and assess the result feels like observing a tiny scientist at work, guided not by instinct alone, but by comprehension of invisible physical rules that govern the world. Dogs dream about their owners. As dogs sink into the stillness of sleep, their paws twitch, noses quiver, and soft sounds escape from their throats. Neurological studies reveal that dogs experience sleep cycles nearly identical to ours, including phases of rapid eye movement, linked to vivid dreams. Within these moments, the regions of their brains that process emotion and attachment activate strongly. This suggests that the figures they imagine most vividly are those they love and trust. Shelter animals who receive consistent affection show calmer, longer periods of restful dreaming, while neglected ones twitch restlessly, reflecting emotional turbulence. The dream state appears to preserve bonds that define their waking lives. A sleeping dog beside its owner may relive shared walks, comforting gestures, or moments of play. Their minds, though silent, replay affection like a quiet film of loyalty. Dreams become a bridge between waking love and unconscious memory, uniting them in trust, even as the world fades to dark. Elephants cooperate to rescue calves in danger. When a young elephant becomes stuck in mud or water, the reaction from its herd is immediate and astonishingly organized. Adults rush to the site from all directions. Some using trunks to pull, others using tusks or feet to dig, while the rest form a protective circle around the distressed calf. Every movement is coordinated through low-frequency rumbles and subtle body signals. Sometimes unrelated elephants join in, suggesting a collective empathy that extends beyond family lines. Observers have seen rescues last hours with patience never wavering. Each individual adjusts its effort based on the other's actions, revealing situational awareness and shared intention. The rescue is both practical and emotional, strengthening the bonds that hold their society together. When the calf finally stands again, the group touches it gently, rumbling in reassurance. It is an act of care, intelligence, and unity that turns survival into a demonstration of collective compassion. Written across the savannah, pigs learn to play simple video games. In experiments exploring animal cognition, pigs have astonished scientists by mastering video game tasks once thought too abstract for them. Using a joystick connected to a screen, pigs learn to guide a cursor towards specific shapes in exchange for treats. Over time, they began to grasp that movement on the screen corresponded directly to their actions. They adjusted quickly to new challenges, demonstrating flexibility and memory. Some even continue playing after rewards stopped, suggesting genuine engagement rather than mechanical repetition. This capacity for symbolic understanding shows remarkable problem-solving ability and emotional investment. To coordinate vision, motion, and feedback requires high cognitive processing, and self-control. These findings challenge long-standing assumptions about animal awareness, proving that intelligence and curiosity are not confined to species we traditionally consider clever. Behind every playful snout lies a brain capable of imagination, a spark of understanding that turns learning into discovery and curiosity into joy. Ravens play games just for fun. Ravens display intelligence in countless forms, but their love of play reveals something even deeper, a delight in the experience itself. In snowy regions, they slide repeatedly down icy slopes on their backs, wings folded, only to climb and do it again. In other habitats, they drop twigs mid-flight, dive to catch them, and invent new aerial games with partners. These behaviors serve no clear survival purpose. They exist for the pleasure of creativity, for the thrill of motion and interaction. Scientists studying ravens have concluded that play refines coordination and builds social understanding. Through such activity, young birds learn boundaries, timing, and cooperation. Yet beyond function lies emotion. They appear to laugh, to take joy in their own performance. The raven's mind balances intellect with wonder, turning ordinary moments into spontaneous art. Each swoop through the air becomes a celebration of thought meeting freedom, of intelligence, finding happiness in motion. Dolphins use bubbles to create rings they play with. In calm waters, dolphins exhale carefully shaped streams of air that twist into perfect circles, hovering like silver halos beneath the surface. They spin these rings with flicks of their fins, nudging them gently or passing them between companions. Calves learn by imitation, practicing until they master the art of stability. The behavior has no survival function. It is a demonstration of precision, patience, and curiosity. Creating a ring requires exact control of breath, motion, and buoyancy, an understanding of physics expressed through play. Observers have compared the phenomenon to painting or music, a performance of intelligence for its own sake. When dolphins chase and burst the rings, they release streams of joyful clicks, almost like laughter. These moments show that consciousness seeks more than food or safety. It seeks beauty. Beneath the waves, dolphins create fleeting sculptures of air, reminders that creativity transcends species, expressed through rhythm, curiosity, and delight. Chimpanzees use medicinal plants to heal themselves. In the forests of Africa, chimpanzees have been seen chewing the bitter leaves of particular trees only when they appear sick or injured. Some select plants containing natural antiparasitic chemicals, while others choose bark with antibacterial properties. They swallow the material whole rather than chewing for taste, ensuring that medicinal compounds are absorbed. Observations show that they use these remedies deliberately, ceasing when symptoms fade. Younger chimpanzees watch their mothers during illness and later repeat the same treatments, proving that the behavior is learned and culturally transmitted. This knowledge represents one of nature's earliest forms of pharmacology, a living example of thought arising from necessity. It blurs the line between instinct and understanding, revealing that healing can begin with observation and experience. In their quiet rituals of recovery, they demonstrate awareness of cause and effect, a wisdom rooted not in words, but in the intelligence of survival and care. Whales modify their psalms when noise pollution increases. Across vast oceans, whales sing to communicate across distances we can barely imagine. Yet, the modern sea is filled with mechanical noise engines, sonar, drilling sounds that drown their calls. Instead of giving up, whales adapt. They increase volume, change pitch, and extend phrases to rise above the interference. When the ocean quiets again, they soften their songs, adjusting dynamically to the world around them. This adaptability reveals not only sensory intelligence, but also cultural flexibility. As young whales learn new variations from their elders, their evolving songs mirror human languages shaped by environment and circumstance. Each shift in melody is both resilience and communication, a refusal to be silenced. The ocean's loudness becomes a test of endurance, and the whales meet it through transformation. Their voices remind us that culture is not bound to land. It drifts and echoes, adapting like the tides themselves, enduring even through the noise of change. Octopuses recognize specific humans who feed them. Octopuses with Their alien grace and many-armed awareness are capable of remembering and distinguishing individual humans. In aquariums and research labs, they approach familiar caretakers calmly while retreating from or squirting water at strangers. Their recognition depends not on scent alone, but on visual cues, confirmed even when caretakers wear identical uniforms. Over time, they form preferences, greeting some people with color changes that indicate excitement. This selective memory lasts for weeks or longer, implying emotional processing and a sense of familiarity. Because their neurons are distributed throughout their arms, perception and learning occur both centrally and locally. Each arm can explore independently, yet all integrate into a single awareness. To recognize a face across species is no small feat. It represents connection. When an octopus lingers by the glass to watch a known human, it becomes clear that understanding and curiosity flow in both directions beneath the water's calm. Bees can be taught to detect explosives and dullness. Bees have an extraordinary sense of smell capable of detecting trace chemicals invisible to human instruments. Scientists have used this natural sensitivity to train them for both security and medicine. By pairing the scent of explosive materials or disease markers with sugar water, bees quickly learn to extend their feeding tubes whenever they encounter the target odor. The process takes minutes and is entirely non-harmful. Their accuracy is astonishing, identifying compounds at concentrations of only a few parts per trillion. Researchers have developed portable systems using bees to detect explosives, landmines, and even early signs of illness in breath samples. These studies highlight not just precision, but adaptability, the ability to link scent, reward, and recognition through learning. In the harm of a hive lies one of nature's finest laboratories where evolution has refined sensitivity into a tool of survival, awareness, and now partnership with human discovery. Wolves use eye contact to coordinate group hunts. In the frozen stillness before a chase begins, wolves communicate without sound. A series of glances passes through the pack, each one carrying direction, readiness, and shared purpose. These brief exchanges synchronize the group's movement more effectively than noise could. As they close in on prey, each wolf anticipates the next step of its companions, adjusting position and speed with breathtaking precision. Researchers have filmed this process and found that packs rely heavily on visual coordination using eye contact and subtle body signals to orchestrate strategy. This requires trust, awareness, and empathy, the ability to understand another's intent. The hunt, though fierce, is built on cooperation and discipline. Through gaze alone, the pack becomes a single organism, guided by instinct, sharpened into intelligence. In their eyes lies not dominance, but unity, a wordless conversation that transforms survival into a shared expression of purpose and understanding. Parrots understand the idea of taking turns. Parrots exhibit remarkable social intelligence, capable of behaviors once believed unique to humans. In cooperative experiments, paired parrots learned to take turns pulling ropes that released shared food rewards. They waited patiently, allowing their partner to act first, and seemed to expect equal courtesy in return. This timing reveals awareness of fairness and sequence concepts essential for communication. In the wild, similar exchanges occur during grooming and duet calls, where partners alternate actions with rhythmic precision. Turn-taking maintains harmony and trust, teaching restraint and empathy. It mirrors the foundations of conversation by listening and responding create meaning. Parrots demonstrate that true communication requires patience as much as understanding. Their deliberate coordination turns cooperation into rhythm, transforming interaction into a dialogue of motion and trust. Within each careful pause and shared glance lies the quiet foundation of intelligence built on reciprocity and mutual respect. Dolphins have cultural differences between pods. Dolphins live in societies as varied as human communities. Across different oceans, pods have developed unique behaviors passed through generations, traditions that define identity. Some use sea sponges to protect their snouts while foraging among rocks, while others chase fish onto beaches in coordinated waves. These practices are taught from mother to calf through demonstration, forming what scientists call cultural transmission. Even their vocal patterns differ, creating dialects recognizable among groups. When pods meet, they sometimes exchange elements of song, blending traditions before parting again. Such behaviors prove that dolphins possess not only intelligence, but culture shaped by geography and learning. Their ways of living reflect shared memory and creativity. In each distinct pod, customs evolve, spreading across families like stories retold through sound and motion. Beneath the vast sea, culture thrives in whistles and waves, carried forward by generations who remember, teach, and adapt. Crows understand cause and effect in problem-solving. Crows approach puzzles with careful observation and reasoning. In multi-step challenges designed by researchers, they learn to use one tool to access another before retrieving food, revealing planning and understanding of sequence. When conditions changed, they modified their approach rather than repeating failure, showing genuine comprehension. Their ability to connect action and consequence mirrors analytical thinking. Some even innovate, bending wires into hooks to reach objects beyond grasp. This creativity stems from their capacity to visualize solutions before attempting them, a process comparable to human foresight. The crow's intelligence lies in adaptability, an instinct that evolves into reasoning through trial, memory, and imagination. Watching one solve a problem feels like witnessing the mind at work. Quiet, patient, and aware of outcome. Each success becomes evidence that logic exists wherever curiosity and persistence unite. Elephants understand human pointing gestures without training. When researchers point toward hidden food, elephants instinctively follow the direction of the gesture without prior experience or reward. This shows they can interpret intention, not just motion. In their own social communication, elephants use trunks and posture to signal direction. So, they appear to transfer this understanding across species. The ability to read nonverbal cues requires complex cognition, recognizing that another being's focus contains information. Unlike most animals, elephants succeed at this naturally without conditioning. Their response reveals empathy, awareness, and cooperation. They see the meaning behind the gesture, not merely its shape. This connection blurs the boundary between species, creating silent understanding between humans and elephants. When their eyes follow the line of an outstretched hand, it feels less like command and more like conversation, a shared acknowledgement of intelligence bridging two worlds through quiet comprehension. Dogs can learn to count small quantities. Dogs possess a natural sense of quantity that helps them make decisions in everyday life. Experiments show that when given the choice between bowls containing different numbers of treats, they consistently choose the larger portion up to about 5 items. They also notice when expectations are violated, such as when a visible quantity suddenly changes, suggesting surprise and awareness of fairness. This ability, known as subitizing, arises from instinctive numerical perception rather than learned calculation. It helps dogs judge competition, sharing, and reward, forming a basis for social understanding. The sense of number ties to trust, allowing them to detect deception or imbalance in human interactions. Their awareness of quantity reflects a deeper intelligence, the ability to represent value and compare outcomes. Within their simple choices lies ancient arithmetic, an intuition that transforms instinct into quiet reasoning shaped by companionship and survival. Chimpanzees remember the taste of specific fruits for years. In the dense rainforests of equatorial Africa, chimpanzees rely on memory as much as strength. They remember which trees bore the sweetest fruits years earlier and return to them precisely when they ripen again. This recall involves more than geography at combined taste, season, and experience. Researchers tracking their movements have seen them bypass unripe trees to reach known favorites at exactly the right time. Such behavior implies mental mapping and a sophisticated sense of time's passage. The pleasure of flavor reinforces memory, creating emotional anchors for navigation. These memories guide younger chimpanzees who follow their elders to reliable sources, spreading knowledge through family lines. The forest, in turn, becomes a living archive of remembered taste and scent. Each return to a beloved fruit is an act of recognition, proof that thought and memory intertwine even in wild silence where intelligence feeds upon sweetness remembered. Ravens console distressed companions. After quarrels or fright, ravens approach distressed companions to offer quiet comfort. They preen feathers, touch gently with their beaks, or sit closely until calm returns. This behavior appears intentional, aimed at reducing anxiety rather than asserting dominance. It occurs most often between bonded pairs or friends who share strong trust. Observers note that both parties benefit, tension dissolving into harmony. Such acts of empathy demonstrate that ravens recognize emotional states in others and respond accordingly. Compassion strengthens their social networks, reinforcing cooperation vital to survival. This tenderness within a species, often associated with cunning, reveals emotional depth beneath intelligence. Their care is not commanded by instinct alone, but guided by awareness. When a raven pauses its flight to sue another, it proves that wisdom is not measured only by problem-solving, but also by the quiet understanding of another's pain. Dolphins use their echolocation like a three-dimensional camera. Echolocation allows dolphins to perceive their surroundings with extraordinary detail. By emitting rapid bursts of clicks and interpreting the returning echoes, they construct a mental image of their environment. But functions almost like a three-dimensional scan. Researchers have found that dolphins can distinguish not only the shape and size of objects, but also internal structures such as cavities or differences in density. They recognize individual humans underwater by the echoes reflected from body contours, suggesting that echolocation conveys an incredibly fine level of resolution. Some experiments indicate that they can even visualize familiar objects when hearing their echoes alone, linking sound and memory as if seeing with their ears. In this sensory world, distance and form merge into rhythm and reflection. For dolphins, sound is both light and language, painting the ocean with invisible sight. Each click, each echo builds a living picture, transforming darkness and depth into a realm of perfect spatial understanding. Octopuses can taste through their skin. The octopus experiences its world not only through sight and touch, but through flavor spread across its entire body. Special receptors on its skin and suckers allow it to taste chemicals directly in the water, turning its arms into instruments of perception. As an octopus explores, each sucker samples the environment, detecting subtle differences in salinity, prey scent, or chemical signals released by other creatures. This ability helps it distinguish edible prey from danger almost instantly. Some species use this sensitivity to avoid toxic surfaces, while others exploit it to track hidden food buried beneath sand. The integration of touch and taste blurs sensory boundaries, allowing them to interpret the ocean through texture and flavor combined. The result is a distributed form of intelligence where information flows through 8 independent yet connected arms. Their entire bodies become sensory landscapes, transforming every movement into a tasting, touching act of thought and awareness. Parrots comfort distressed companions. Parrots, with their bright plumage and sharper minds than once believed, show remarkable empathy toward one another. When a flock member becomes frightened or upset, nearby parrots often approach and gently pin the feathers of the distressed bird. They may nuzzle close, mimic calming sounds, or perch quietly beside the companion until its agitation subsides. Thanks for watching, and like and subscribe, share please.